So let's talk about the second half of day one's review. The problems on this page we didn't actually do because we weren't able to go through every single lesson in our book due to the fact that we've got the waiver days and the e-learning situation. But I still think you can do these problems once you see me doing one and talking about it and then modeling that onto the problem that you're going to try for me. I do think you can do these. I have faith in you. So we've got these quadratics, numbers 11 and 12. I'm doing 11, you're going to do 12. And I can tell that it's a quadratic function because of the x squared. So we have 2x squared minus 4x plus 3. And I did the video for you on the characteristics of quadratic functions. We also talked about the graphs of these in that family of functions lesson. But when we see a quadratic function, it's going to be a parabola. And it's going to look like a U, like it does here in number 11, or sometimes it's going to be upside down. And we know it's going to be an upside down U if that leading coefficient is negative. So here's a big hint. If you look at number 12, your graph should be an upside down U because your leading coefficient's negative. It asks for these attributes, the vertex, axis of symmetry, y-intercept, and whether it's a minimum or maximum value. And it gives you a table. So I just picked values that fit on the graph. So I picked my x values. I'm not really sure why this one has a box. Maybe they wanted me to be magical and know where the vertex was, but I didn't until I started graphing it. But I just picked x values that fit on the graph. So don't pick things like -7, because that's not even on our graph. Pick things that make sense. So I started at -2, and I did -2, -1, 0, 1, and 2. And then as I started plugging in values, I realized, well, hey, it'd be really nice if I had 3. So I added 3 on there. So I just picked x values that made sense from my graph, and then I plugged those into the function in my calculator, and I got these points. So when I plugged in -2, my calculator told me y was 19. If I plugged in -1, my calculator told me y was 9. When I plugged in 0, calculator told me y was 3. When I plugged in 1, plugged in 2, plugged in 3. So I did a lot of plugging and chugging with my calculator, and then I plotted these points. Well, -2, 19 didn't fit on the graph, so it's not on here. -1, 9 did. So that's the first point that I graphed. 0, 3, 1, 1, 2, 3, and then 3, 9. So I had those 5 points. And then I just connected them and drew the arrows on the end. Don't forget arrows. You guys know I'm weird about the arrows because it goes on forever. So from this, I'm able to tell where the vertex is. Remember, the vertex is the turnaround point. So the lowest point here, because this one opens up, is at 1, 1. So the vertex is that lowest point. The axis of symmetry is the line you could fold the parabola over, and it would be symmetrical. So if we picked up our paper and folded it across that line I just drew in, then we would match those pieces up exactly. Well, if my graph was exact, but you guys know my graphing's awesome. So this line is the vertical line x equals 1, and that's your axis of symmetry. So that's where I got that from. My y-intercept, well, the y-intercept is just where it crosses the y-axis. So that's the point 0, 3. And does it have a minimum or a maximum? Well, these arrows tell me it goes forever. So it's never going to have a maximum. So the smallest, the minimum, happens at the vertex. And that means the smallest y value is 1. So the key on these is picking values that make sense from the graph that's given to you for your table, plotting the points, connecting them, and seeing if you can identify these pieces. It's good practice. 13 and 14, I did 13, you're going to do 14. Here it asks you to sketch the graph by finding the vertex and the x-intercepts. Well, the vertex is the highest or lowest point. And we did that when we were finding those projectile motion questions. So I'm going to show you how to do that, how to find the vertex. And the x-intercepts, you've done a lot. You just might not have thought about that's what they're called. But that's when you set the quadratic equal to 0. Because if I'm touching the x-axis, my y value is 0. So the work for both are down here. So to find the vertex, we use that idea that the x-coordinate of the vertex, which is the highest or lowest point, is negative b over 2a. So from this particular problem, b is 2, so negative 2 over 2a, but a is 1, so 2 times 1 is 2. So I got negative 2 over 2 is negative 1. So that says x is negative 1. But then I needed to know what the y was. So this was when we were doing those projectile motion questions. This would tell us the time, and then we'd have to plug it back in and find the height. So that's what we're doing now. So I took negative 1, and you can see all I did was write out what I typed in my calculator, because I put negative 1 in everywhere that x showed up, and I got negative 4. So the vertex is the point 1, negative 4. And that's how I drew that dot. Then to find the x-intercepts, that's when the x value that gives us an output or a y value of 0. So we just set it equal to 0. Well, how did I factor this? I did a diamond problem in my head. I cheated a little bit. What multiplies to negative 3 and adds to 2? Well, it's 3 and negative 1. So that's how I got x plus 3 and x minus 1. If I set each of those equal to 0 using the zero product property, x is negative 3 or x is positive 1. So we have the point negative 3, 0, and we have the point 1, 0. And I just did my best to connect them in an upward facing U because my leading coefficient is positive. Okay, we've got just a couple more. You can do it. I have full faith in you. We've got projectile motion up here. 15 and 16 are projectile motion. If I talk about this too fast, go back and watch that video because I think we did a nice job talking about those problems on those days. We've got our function. Sandra's throwing a ball, the equation of the pathway. It's unfortunate that this says his because I wouldn't name a boy Sandra, but it's fine. To each their own. The height is equal to negative 16t squared plus 12t plus 8. So we want to find the maximum height. That's how we know we want the vertex. So to find the t, how long it takes for that to happen, we do the negative b over 2a. I plug the b and the a into that, and I get 3/8. Negative 12 over negative 32. I just reduced that fraction, they're both divisible by 4, to get 3/8. So that means 3/8 of a second go by when the ball gets to its highest point. So 3/8 is t. So if you look at the function they gave me, h equals negative 16 t squared. Well, I took t out and I put 3/8 in its spot, plus 12t. Again, I took t out and I put 3/8 in its spot, plus 8. Then all I did was type that in my calculator. I let my calculator do all the work for me, and it spit out 10.25. It did not tell me feet, but please make sure with a story problem that you always have a unit. Okay, 17 and 19 are also problems we didn't do, but I think you guys can because you're smart people. We've got an exponential function. You should be able to identify that it's an exponential function after doing the family of function lessons because the variable's in the exponent. That's our giveaway. So we should have some idea what the graph looks like. What I want you to do is to pick values and make an XY table. Again, pick things that make sense for your x values from the graph. If you look at this graph, it doesn't make sense for you to pick negative 14 or positive 10 as your x values because they're not on here. So pick values that make sense. Again, I just went with the classic negative 2, negative 1, 0, 1, and 2. Then I added 3 because I knew it would fit on the graph. If you plug in negative 2 for x, you should be able to type that in your calculator and it spits out 0.5. I wrote a half because you guys know I don't like decimals so much. If you put negative 1 in for x, you're going to get out positive 1. If you put in 0 for x, you will not get 0. 2 to the 0. Anything to the 0 power is 1. So 2 times 1 is 2. If you plug in 1, you get 4. If you plug in 2, you get 8. And if you plug in 3, you get 16. Then these are points that you can graph. I have confidence that you guys can graph. So negative 2, 1/2, negative 2, halfway, negative 1, 1, 0, 2, 1, 4, 2, 8, and last but not least, 3, 16. And then you can see I just did the best that I could to connect those dots together. So for number 18, that's what I want you to try to do for me. It's okay if you get stuck. It's okay if you get a little frustrated. Ask me questions, but I just want you to try. And then 19 and 20 should be a giveaway that those are absolute value functions if you did the family of functions lesson because they have absolute value symbols in them. So that tells me that they're going to be V's. I know that my graph is going to be a V. They're moved around a little bit because we've got -3 and this +3 happening. But then it's just a matter of figuring out where do they go. So how did I know to start with 0? I didn't put in any negative numbers. And I'll tell you, I did do one in my head. And then I realized I didn't need them. So sometimes it's just trial and error. I put in negative 1. Negative 1 minus 3 is negative 4. The absolute value of negative 4 is 4. 4 plus 3 is 7. So that meant I would have had negative 1, 7. And that meant it was off the graph. If I put in negative 2, it was going to be even farther off the graph. So that's how I know to start at 0. I didn't just know, I tried. So I put in negative 1 first in my head, and I saw that it was going to be off the graph. So then I said, well, Miss Ball, you need to move over to the right. So I just started with 0, and I did 0 through 6 because they all fit on the graph. If I put in 0 for x, I got out 6. If I put in 1 for x, I got out 5, and so on down the line. Your calculator will not do absolute value for you, so your brain has to think about it a little bit. If I put in, for example, 2. 2 minus 3 is negative 1, but the absolute value of negative 1 is positive 1. So 1 plus 3 is 3. If you get all your points, so again, I've got all these points, 0, 6, 1, 5, 2, 4, 3, 3, 4, 4, 5, 5, 6, 6. Again, I'm just plotting points as I go down the table. I know my graph should be a V because it's absolute value. If you plot your points and connect them and it's not a V, go back and see where your mistake's at because it needs to be a V for problem number 20. Okay, I know that's a lot of stuff. Do your best. Ask me questions. You guys can do it.